electronic communication systems. Elements. So what are all the elements are using in the communication system? That first one is input signal. Input signal means we are applying that music, sound, data, or picture, or whatever it is. That is called input signal. That input, next one is input transducer. Input transducer means we are converting the sound energy into electrical energy. For example, microphone. So microphone is converted that sound energy into electrical energy. Like that, if that energy is converted from pressure and pressure, sound, and under that, depending on the nature, it is converted into electrical signal. That devices are called input transducers. Input signal maybe it's in a sound, music, picture, video, this or data. That's called info. It's converted into electrical signal. That is called input transducer. Then transmitter. Transmitter means it transmits the signal. So how that signal is transmitted is here. This is the input device. Input device, for example, you can take that mic. Mic is converted that sound energy into electrical energy. That is input transducer. Then the signal is given to the amplifier. So amplifier means that amplifier amplifies the signal. Initially, it converts the signal is in a weak. So that signal was amplified by the amplifier. Then the signal is given to the modulator. Here you can see that oscillator. That work of the oscillator is producing the high frequency carrier wave. So it's the signal. It is produced by the input transducer. Oscillator produces the carrier wave. So carrier wave also sent into the modulator and signal also sent into the modulator. That modulator superimpose the signal wave into the carrier wave. So after modulator that wave that is transmitted to the power amplifier. So the power amplifier gives the energy to the signal, that is power. It gives the power and it is amplify the signal. After amplify that signal, then it is given to the communication channel, that is the antenna. So from that signal is transmitted into the phase or the medium. So it's called transmitter. Then transmitting antenna. Transmitting and the signal energy into the space. So we converted all the things in an electromagnetic wave. You know that electromagnetic waves are traveling with the velocity of light 3 to the power of 8. After that, the communication channel. Communication channel means the medium. How that signals are transmitted into the transmitted to the receiver without any noise or the distortion. That communication medium basically it has the two types. One is the wireless communication. Another one is the wireline communication. Wireline communication means it is point-to-point communication. You know that. So we are using the intercom and cables, optical fiber. Optical fiber, you know that. The road side la கருப்பா ஒரு wire போட்டு வச்சிருப்பாங்களப்பா. அதான் வந்து என்னதுன்னா optical fiber. So that is point-to-point connection. Intercom and cable TV connection. These are all the wireline communication. So it is point-to-point communication. So these are the example for the wireline communication. Next one is wireless communication. Here the wireless communication is used to transmit the signal in a very long distance. Example for that, telephone, intercom, cable TV. So these are all the example for the wireless communication. That is wireline communication. Wireless communication is used for transmitting the signal in a long distance. Example for that, TV, mobile, radio, TV broadcasting and satellite communication. These are the examples for the long distance transmission or the wireless communication. Next thing is noise. Noise means it is an unwanted electrical signal or undesirable signal or the frequency is mixed with the signal. So this can be man-made signal or nature. Man-made signal, you know that automobile sound or welding machine, electrical motors, like that. You know, you can see that the lines are produced on the TV when you are switching on the mixie or grinder. There is a man-made noise. And the another one is the natural, lightning, radiation from the sun. So environmental effects are the natural effect. So this can be produced with the noise in the signal. Next one, receiver. And receiver, the receiver is the reverse process of transmission. See, this is a reception. Here the signal is transmitted from this antenna. The transmitted signal is received by the receiver. Here antenna is used as a receiver and it is a transmitter. Here the antenna receives the signal. After receiving the signal is given to the radio receiver. The radio receiver receives the signal, then it is given to the demodulator. Initially it is modulator in transmission. Reception it is a demodulator. Demodulator extract the signal from the carrier wave. Extract the signal from the carrier wave. So it is separate the signal and carrier wave. That carrier wave is here and signal is given to the baseband signal. So this is the signal which we send into the transmitter. So that signal is given to that amplifier. So that amplifier amplifies the signal. Then it is given to the output transducer. Input transducer, you know that is a mic. For an example, here that you can say the example. Output transducer is the speaker. Here the electrical signal is converted into sound signal, sound energy. So that is output transducer. Input transducer, it converts the sound into electrical. Output transducer converts the electrical signal into sound. So it's a receiver. So these are the parts are used in the receiver. Okay. Next one is repeaters. Repeaters means that signal is received by the receiver. Again, it is amplified and retransmitted. That is done by the satellite. So it is receiving the signal and it has the transmitter and the receiver both. So initially it is received the signal and it is amplified the signal and it is given transmitted to the earth. That is doing by the satellite. So satellite communication, the signal satellite is the example for the repeaters. Then output transducer, you know the attenuation. That means loss of energy. When the signal is transmitted in a very long distance, definitely small part of the energy is lost. That is the signal strength is decreased. It's called the attenuation. Then last one is the range. Range means that maximum distance. That means from point of transmission to the point of reception. That is distance is maximum distance. That is called the range. So how long that signal can be transmitted. Next one is bandwidth. Bandwidth means the frequency range. So the signal is transmitted from the starting frequency. For an example, it is 10 Hz up to 100 Hz. That range, that frequency range is the baseband signal. That is voice, music, picture, like that. So it is transmitted. That frequency is called the bandwidth. The type of communication is depending on the different frequencies. That's called upper bandwidth and the lower bandwidth. The bandwidth means the signal transmitting frequency value from starting value to the final value. Suppose you can take that mu1, mu2 are the two frequencies. So mu2 is the greater frequency, mu1 is the initial frequency. The bandwidth means the difference between the higher frequency minus lower frequency. Upper frequency minus lower frequency is called the bandwidth. So this is the bandwidth. Then bandwidth of transmission system. எப்படி வந்து transmit பண்றோம் அப்படின்னா the range of frequencies required to the transmit of piece of specific information at a particular channel is called bandwidth. You know that example. For an example, you can take the Sun TV. Sun TV, it has a specific bandwidth. In that particular bandwidth is given to the Sun TV. When you are tuning the TV, it starts from the VHF-L, VHF-H, UHF. அப்படின்னு டியூன் ஆகுது பார்த்துருக்கீங்களா? When you are tuning that frequency, it will start from VHF-L, VHF-H and UHF. VHF-L அப்படிங்கிறது என்ன அப்படின்னா very high frequency for lower band. VHF-H அப்படின்னா very high frequency for higher band. UHF அப்படின்னா that is ultra high frequency. So we are giving the different frequency. Here ultra frequency you can't receive any channels because ultra high frequency is given to the mobile communication. That's why there is no channels in that particular frequency. So when you are tuning the circuit, it may be start from 0 to 800 megahertz. That is the frequency given to the total channel. In that channel, that particular frequency width, that is bandwidth given to the one particular channel. So that is called channel width. So you know that here suppose you can see that 5 kilohertz is the channel width, and it can be transferred in the 10 kilohertz. 10 kilohertz. That means இப்போ நான் என்ன சொல்றோம் 5 kilohertz சொல்றோம், பட் இது எப்படி டிரான்ஸ்மிட் ஆகும்போது 10 kilohertz இருக்குன்னு சொல்றோம். எப்படி அப்படின்னா signal and carrier wave. So this is a transmitted signal. They are giving the 5 kilohertz. 5 kilohertz means this is the input signal. You can take in this is a 5 kilohertz. This wavelength is, this wave is superimposed on the carrier wave. So this is the 5 kilohertz. So this is enough for that 5 kilohertz. But you see that another one waveform is here. That is also 5 kilohertz. When you are transmitting that 5 kilohertz, it has the 10 kilohertz. That means upper sideband and lower sideband. So two transmitting signals are there. So we can use that two bands in the different channels. So that's called the channel bandwidth. Twice the signal frequency. That means upper sideband and lower sideband. This is because the amplitude modulation, the bandwidth is twice the signal frequency. So that is required to reduce the channel bandwidth to accommodate more number of channels in the available electromagnetic spectrum. So we can send the large number of channels in that particular bandwidth. So in some application, modulation is selected based on it. So you can tune the TV, you can say able to see the all the frequencies for that particular wave, particular bandwidth for each and every channel. Next one is antenna type. So we have to transmit the signal. That what should be the height of an antenna? That should be the multiple of lambda by 4. That is height of the antenna h is equal to lambda by 4. Where lambda is the wavelength, or you know the formula for c equal to mu lambda. That's the important formula. From that we can define lambda equal to c by b, where c is the velocity of light and mu is the frequency. Here they are giving that one example. So transmitting signal, that is signal. That voice, suppose you can take that is my voice. My voice is a 10 kilohertz. It is transmitting signals. Modulated wave is a 1 megahertz. That is carrier wave. So what is the size of an antenna required for transmitting these two frequency means using that h1 equal to lambda by 4, lambda equal to c by b. Substituting that value here. C equal to 3 into 10 to the power of 8, 4 into 10 into 10 to the power of 3. 10 kilo means 10 into 10 to the power of 3. Kilo means 10 to the power of 3. That is 1000. So substituting all these values, you will get 7.5 kilometer. So you are transmitting the 10 kilohertz frequency. You require the size of antenna is 7.5 kilometer. And you can see that 1 megahertz. 1 mega means 10 to the power of 6 mega. 10 to the power of 6, you know that. So substituting that value, you get 75 meter. So 75 meter is possible for instead of 7.5 kilometer. So after modulated that wave only we can transmit it in a 75 meter antenna. Before modulating that signal, you require the 7.5 kilometer size of an antenna. So it is not possible to transmit the signal. That's why we are modulated that way. After that only we are sending. So after modulation, you can require that 75 meter size of an antenna. Using that we can transmit the signal. Right? So this is an antenna.